Good afternoon, everyone. Good afternoon again. I'm Henrietta Budai, the Secretary General of Hungary Green Building Council, and I will moderate this Green Talk today. This time we don't have our Green Talk event in Hungarian, but in English. And I would like to share some technical information with you before we start and before I present our speakers of today. So some details. This Green Talk will last for 1 hour and we will have 2 presentations. Each of them takes 20 minutes. And after that, the presentations, we will have time for questions and answers and discussions. And we kindly ask you that if you have any questions during the presentations, please click on the Q&A button in the bottom of your screen, and you can type your questions in it. And if you have any technical thing to share with us, please type in the chat box. And it is very important that the event and the lectures will be recorded and can be seen in the YouTube channel of Hungary Green Building Council. And now let's talk about the event and the topic of today. So today we will speak about the net zero whole life carbon and how life cycle assessment can help to reach net zero whole life carbon. There are a lot of terms in the title. What is net zero? What is whole life carbon? What is life cycle assessment? And our lecturers will explain all terms during their presentations. Now this is time to introduce our speakers. First of all, I welcome Carolina Aitocalio from One Click LCA, and she will explain how to assess the circularity of building through the life cycle assessment methodology. And then we will have a Hungarian project, and it will be presented by Lennart de Klerk, who is the owner of Irota Ecolodge. This is the first carbon neutral touristic building, and 3 buildings, of course, in Hungary. So I let the word to Carolina to have her presentation.
Thank you, Henrietta. Good afternoon, everyone. I will be sharing my screen right now. So, yes, let's talk a little bit about circularity in buildings. So as Henrietta said, my name is Carolina Aitocalio. I'm a business developer at One Click LCA. And we at One Click LCA, we have the mission of powering the makers of a zero carbon future. So today, let's just break down a little bit my talk in a program. So I'm gonna at first do a quick introduction to One Click LCA. Then we're gonna talk about the life cycle assessment process, what is building circularity, how to apply building circularity to buildings, and finally, building circularity with the help of One Click LCA, in which I will do a quick demo with the software. So about One Click LCA, we are the world's leading construction and manufacturing LCA software. We have solutions in terms of software for buildings, infrastructure, manufacturing, corporate greenhouse gas reporting. We are present in over 130 countries worldwide. We have all the publicly available EPDs added to our database, making it the largest database in the world. We can integrate with other 15 different types of software, including Excel, Revit, Rhino, and others. We have today a staff of about 100 people, and we are a Finnish company based here in Helsinki with over 20 years of existence. We are able to connect the entire industry because we offer solutions for the entire industry. So for example, manufacturers want to do the assessment on their products and issue environmental product declarations that will then be used and specified by architects and engineers, bought and also used by builders, investors, and institutions, and also in those in their calculations as well. In one-click LCA, we have solutions for each phase of the project, and we also need to have in mind that the potential for decarbonization of the project halves as each stage of the project moves forward. So to sum up, we are a global platform with global data and tools for global compliance, also complying with certifications as well. We make then carbon easier to understand and to act on with a very much user-friendly tool that offers results, both numerical results and graphic results that can help your clients also understand carbon. So let's talk a little bit about the life cycle assessment process. Why the life cycle assessment process is important? Because the construction segment is responsible for more or less 40% of the carbon emissions nowadays, and the global building stock will double in about 40 years. This means that we will be building in the next 40 years a New York City every month. The way to quantify this and to actually take action in this matter is through the life cycle assessment, because it evaluates the whole life cycle, as it has been said, of this process in the construction industry. And how the life cycle assessment works. So we have different sources of embodied carbon across the construction process and life cycle. So for example, we have the A1 to A3 stage, in which we consider the extraction of raw material, transport to manufacturing facility, and the manufacturing process. Then we have the A4 to A5, which is the transport from the manufacturers to the construction site and then installation. Then we have the B phase, which is all about the use stage. And here we have everything in terms of use, maintenance, repair, replacement, and refurbishment. And lastly, we have the end of life stage, which considers the deconstruction, demolition, transport, waste processing, and disposal. The end of life stage comes usually after 50, 60 years, depending of the regulations that we are doing our calculations based off. And it's the final stage of the building after the use. However, we have some more stages that we need to take into consideration if we are going to be working with European norm standards. So, for example, in the B stage, we have the operational energy and water use, and we also have the D module that talks about benefits and loads beyond the system boundary. So in terms of life cycle assessment, this is how it is done with this breakdown of stages. And in terms of whole life carbon, the difference of whole life carbon is that it considers other impact categories beyond just carbon and biogenic carbon. So it considers also acidification, eutrophication, ozone depletion, and others. So what is building circularity? Building circularity is a way to measure the circularity of a building and a construction of a building. So there is no norm in place for building circularity at the moment, but there are principles and metrics, and some of the most well-known and used are from the UK GBC, HQE Economie Circulaire from France, the London Planning Circularity Statement, and the Ellen MacArthur Foundation Circularity Indicators, which are very much intertwined. So for these principles and metrics, what they consider are only the manufacturing stage and the end of life of the products of this building. So also in terms of certifications, BREEAM also considers credits for the circularity assessment. And within this consideration also, we need to think about a few other elements. For example, the design in the buildings. So is the design made for assembly, disassembly? Is it made for adaptability, flexibility, longevity? And also the reuse potential and the impact of the materials. And also if we are designing out of waste, for example, using recycled materials. And now just a quick question before we explain how the breakdown is made in terms of the impacts for building circularity. At the end of life, we have two different types of materials, the materials that are downcycled and the materials that can be used for energy. So how do you think those materials are accounted for in terms of circularity, for circularity purposes? Do you think materials that are downcycled and used for energy are fully accounted for, are only accounted for in 50%, or are not accounted for at all? Let's give you some time to give your opinion and vote. Okay, so I guess we have here the majority of you, 46%, think that it's 50% accounted for. And you are correct, it is 50% accounted for. Let's have a look at how the circularity principles are used for circularity purposes. So we have here at the top of our circularity assessment, the materials recovered, in which we can find all the materials that are used in the construction of the building. So here we have virgin materials, renewable materials, recycled materials, and reused materials. And for circularity purposes, virgin materials are not considered at all, but all the other materials are fully considered. So the sum of materials recovered here is 4.1% from the renewable, recycled, and reused materials. At the bottom, on the other hand, we have the materials returned, which are materials that come from the deconstruction process of the building after the life cycle has happened with the building. So here we have the use as material, which is fully accounted because it's a material that is used as the same quality, same type of material. Then we have recycled materials that are also fully accounted for. We have downcycling and use as energy materials that are accounted for in 50%, as you guys now know. And the disposal materials that are not accounted at all. So the sum of those materials are the materials returned, and our circularity score is the calculation of the average between the materials returned and the materials recovered. So how do we apply building circularity to buildings? We have some principles that we can work with. For example, we can combine it with other life cycle assessment or life cycle costing calculations. We have to be aware of the weighting principles, which are mass-based, and the calculations are mass-based, and the weighting principles are the ones that we just discussed about at the moment, the last slide, sorry. And we have to also understand the scope of the calculation that considers all the materials in the period given, including site wastage, replacements, and end of life. And what does it cover? So it covers the reduce, reuse, recycle principle, value preservation, design for adaptability, and design for disassembly practices. The users of one-click LCA that use this tool, the building circularity, what do they need to know to do this assessment? Basically, the materials and their quantities, and also refine from the default values the percentage of reused or recycled materials, the shares of waste, and also if they are made for design for disassembly and adaptability, if that's the case. The calculation percentage, once again, is 100% linear, taking into consideration the weighting principles. So in terms of the software and how to work with it, we have here, the first column is the resources column. So here we are having a look at the foundations and substructure part of the building. So in the resource column, we have the materials, then we have the quantities and the quantity types. We can add any comments that might help us with this assessment. We also need to do the input of the share of recycled, renewable, and reused percentage. according to the materials, the wastage as well, and also confirm if they are going to be used for design for disassembly and design for adaptability, as well as choose our process for the end of life. Then in terms of results, we can have results for materials recovered and materials returned, not only in the graphs, but also in numeric terms. So here we see them in tons. And also we can see the material group, the key material groups. So the materials that are the most responsible for the circularity score, and how so. So for example, here we have concrete with a very high amount in the downcycling and use for energy, uses energy. And now let's have a look at how to work with building circularity with the help of one-click LCA. So here I have a project in which we have our levels lifecycle carbon tool, and we have our building circularity tool. We have two projects, the baseline and the proposed design. And we can also compare them down here, the two projects. So if I click here on my circularity score from the building circularity, I can see the data input tabs. So the building materials, the circularity weighting factors, and the calculation period. In the building materials, we will see what I just showed. So here we have the foundations and substructure. We can do the input of those materials either manually here by typing or clicking in the arrow, or we can also import from one of our more than 15 different types of integrations. Then we need to do the input again of quantities, a percentage of recycled and so on. If we import from other sources, we don't have to do the input of all of it. Usually the type of material, the name of material, and quantity, also quantity type, are already present in the importing. We have then the circularity score and weighting factors that are displayed here, as we mentioned before. This can also be altered if you're working with different principles for circularity. And we have the calculation period, which here is 60 years for this project. Then we can have a look at the results. And in the results, we have our graph that we just had a look at. We have also the results that we saw earlier. And we have also here the materials that are a list of materials that I have selected for design for disassembly and adaptability practices. So we have also different types of graphs that can illustrate these results. So we have our basic graphs here, and then our advanced graphs, so bubble, Sankey diagram, tree map, life cycle stages, and so on. Let's go back to our presentation. And what other tools can we use with building circularity? We can use the levels tool, which is the one that I used for the project that I just showed. We can use the carbon designer 3D, which is an early stage tool, the lifecycle costing tool, LCC, also for BREEAM, as I mentioned before, and also our net zero carbon tool can be used in connection with the building circularity tool. For this webinar, we have a special offer for existing and new customers. So if you could please reply to the post-webinar survey that will be posted in the chat, we can offer you 30 days free for the building circularity tool. So with this, thank you very much. If you have any questions post-webinar, please feel free to contact me, and I will pass the word to my fellow speaker, Lennart de Klerk. Thank you.
Thank you very much, Carolina. Now I say some words about Lennart's presentation, but first of all, I will ask my colleague Zsuzsa to share the survey link in chat, because you shared for only panelists, not all the audience. Thank you very much. So it was very interesting to see the one-click LCA tool live. So I really encourage our audience to live with the free trial and put your data in it and try what are the results. And Leonard will show this graph. You mentioned, Carolina, in your presentation, and you presented with real data. And we are very happy that we have Leonard in Hungary and the Irota Ecology project, who can speak about the real life data. And what is very important, I think, in the life cycle assessment as well, in this context of today, that you reach, Leonard, the zero overhead costs, meaning running the whole holiday venue. And I think it's very important today. So let's hear about your project and the best practice of you. Thank you.
Yes, thank you. Thank you very much, Harriet, for the introduction. I'll start sharing my screen. And yes, indeed, you know, what I would like to do in this presentation is show you a real life example. And this is all because we working on whole life net zero carbon. And just to remind everyone on what we're talking about. So we're talking about the total carbon emissions over the full life cycle, the whole lifespan of a building. So that's what we call whole life carbon. And that consists of two elements. One is embodied carbon, and embodied carbon is defined of the carbon emissions due to the construction of the building, the replacement and refurbishment during use, and at the end of the lifetime, the demolition. Whereas operational carbon is the carbon emitted for using the building as such. So you should think about heating emissions or the usage of electricity while using the building. Other elements, and I will talk about it soon, is about biogenic storage, exporting energy if you produce more electricity, for example, than you consume. And if you have any carbon emissions remaining, you might offset them through projects. But I would like to start with the poll now, because the World Green Building Council has set a whole life carbon vision. And that consists of several elements. And you see here 3 statements. And only 2 statements are correct. 1 statement is wrong. So I'll read them out. By 2030, new buildings should be net zero for operational carbon. By 2030, existing buildings should be net zero for embodied carbon. And the third one, by 2050, new buildings should be net zero for whole life carbon. So that's operational plus embodied. So I guess, Zsuzsa, you've started the poll?
Yes, she did.
Okay.
It's running.
So I'll...
Well, Lena, don't you see the screen, the result of the poll?
I don't see it.
But I can tell you, maybe.
Yeah, if you can, please do.
The second answer got the score of 71%.
Mm-hmm.
And the first and the third one got 14%.
Yeah.
Of the answers.
Okay, that's very good, because indeed the second statement is incorrect, and I'll explain you why. Because you know, if you want to have net zero embodied carbon, you would always be talking about new buildings. If a building already exists, you cannot make it net zero as long as it's we're talking about embodied carbon. So the first vision, the first statement is really, you know, to encourage people to be operational net zero carbon by 2030, and then by 2050 as actually whole of Europe should be net zero carbon, it also means that all the buildings should be whole life carbon net zero. So going to the presentation, Irote Ecolodge is a small holiday resort in the north of Hungary. We are between Miskolc and Košice in the Slovak Republic. And I'm also happy that I've been told that also a lot of people from the Slovak Republic have joined this GreenTalk. So be welcome. And what we wanted to achieve when we started this project in 2015, so that's already 7 years ago, we wanted to show for the hospitality industry that luxury and sustainability go well together. Whereas often sustainability is associated with simple life, we wanted to show that both elements, luxury and sustainability, perfectly go together. It consists of 3 large villas, 170 square meters each, which can house 6 persons per villa. And it has a shared natural swimming pool, which is the size of 6 by 16 meter. And we opened in 2016. And when we designed these 3 villas, we wanted to be as sustainable as possible. And one important element was to make use of reusable or reused building materials as much as possible. Those days, the word circularity was not very much in vogue. I hadn't heard about it those days. But still, looking at it now, it comes very close to circularity if you are using reused or reusable building materials. Also on the sustainable solution, so it has PV systems, solar collectors for hot water. The heating is with biomass, with firewood. We collect rainwater for flushing toilets. And the swimming pool itself is natural, so we're not using any chemicals here. And what we wanted to achieve is a climate neutral operation. And that's actually what you can see in here. These are our operational emissions for scope, also better known as scope 1 and scope 2. And here it's important to realize this is not only the building, the holiday resort itself, but it includes the full operation of our business. So you see first Irote Ecolodge itself, but we also have a utility building where we're doing the laundry. We're renting out an apartment in Budapest as well, the Budapest City apartment. And on the 4th transport item, these are our company cars that are using fossil fuel. And as of recently, also we have an electric car. Anyway, if you look at the net emissions, they're below 0. So here we can claim that we are a carbon neutral operating holiday resort. But actually what we did want to have a look at is indeed what have been our embodied emissions when we built Irote Ecolodge. And if we look on the whole life cycle, are we still a net zero as well? So with the help of the one-click LCA software that Carolina just presented, we did a retrospective analysis of one villa, but as the 3 villas are very similar, basically you can copy the results from one villa to the other. And just to give you a little bit of an idea, here this is a picture of the foundation, and as you can see, we're using reinforced concrete. They're pouring the concrete here at the moment. And as we all know, cement is, from a carbon perspective, a rather dirty building material. But unfortunately, for foundations, there are not many low carbon alternative available as of today. But what we built on top of the foundation is different. And here you can see the reused or a reusable building material. On the left side, you see the timber frame construction, and wood is perfectly able building material that at the end of the life cycle you can disassemble and use the wooden beams for other buildings. On the right side, you see cellulose, which is a building material made from newspapers, impregnated with a fire retarding agent. And with these cellulose, we insulated the floor, the roof, and also all of the walls. So we inserted all the materials that we used into the software because it's a building that already exists. So we had very specific and very precise quantities of building materials that we used, and we came to this result. So here you see the different life cycle stages, and the bigger a certain square is, the bigger the emissions were or will be. And not surprisingly, you see here ready-mix, different ready-mix. So ready-mix, that means concrete, ready-mix lightweight, ready-mix foundations, concrete products. But if you add up all the concrete, you see that they are consisting, a large share of the emissions. Also, you see a large square, which is called bricks. This is on the left down square. And actually, the wording is incorrect. It should have been the roof tiles, but the roof tiles are made of clay. And also for me, it was actually a surprise to see that roof tiles have such a big impact on the carbon emissions. Another one to have a look at is rebar. That's the steel that we used. Normally, steel has a much bigger impact on the carbon emissions. But we were able to get the steel from the Oost steel factory, and they are only using recycled steel, which has a relatively low carbon emissions. But anyway, I think it's this life cycle assessment really helped to get a better insight, in the building, where are the emissions, and again, not a surprise, but the largest share of the emissions are in the building materials as such. And here you can see the result. The embodied carbon of this building is almost 300 kilo of CO2 equivalent per square meter. And if you benchmark that against average buildings in Central and Eastern Europe, you can see that we are in the A category. And that's not so much because of the foundation, because that's fairly standard, but because what we built on top of the foundation is a relatively low carbon. We did have it verified by the Hungarian company GreenTalk Consulting. So they checked whether the data we supplied was correct and was justifiable. Unfortunately, for the building materials that we have used, only very few environmental product documentation was available. So we had to do this calculation based on a lot of default values. but let's hope that in the future also more suppliers of building materials are able to also deliver this EPDs. So here we see the result again on the first column. That's the total life cycle impact, which is almost 82 tons of CO2. And that's not below zero. However, we have two elements that we did not take into account in the calculation of the total life cycle impact. First one is the what we call the total life cycle avoided emissions. In our case, that meant we have a large PV system on our roof, and we're only using about 45–50% of the generated electricity. And the remaining electricity we deliver to the grid. And as a result, we are avoiding emissions somewhere else in the Hungarian grid, so less electricity has to be produced by coal or by gas. And as a result, over the full life cycle, we significantly avoid emissions. So that's a factor that has negative carbon emissions. But in the third column, you see the so-called biogenic carbon storage. And biogenic carbon storage means that the building materials that you've been using, and in our case, that's timber and cellulose, is based on natural building materials, based on trees that were growing. And while the trees were growing, they were taking CO2 out of the atmosphere and stored it in the wood. And by using a lot of biogenic building materials, we in this villa have also stored a lot of carbon. And I must say, also to my own surprise, this was quite a big amount in terms of CO2. And if you, as a result, add all the three columns up, you get to the net emissions, and these are below zero. So we were actually very happy and proud that Irota Ecology is not only a net zero operational company, but a company or an object that is net zero carbon over the full life cycle. So as you've seen, the Green Building Council has set a vision to reach this aim in 2050. But we, and I must admit, not knowing, but we reached this milestone already in 2016 when we delivered the 3 holiday homes. Now, it's not for there is a reason why this biogenic carbon storage is set separately, because it's still a bit up in the air in the regulatory world. Are you allowed to subtract the biogenic carbon storage from your total life cycle impacts? And the reason is what will happen with all the building materials at the end of the life cycle? Because if you, for example, would incinerate all the wood, the biogenic building materials, then basically the carbon comes back into the atmosphere, and that's of course a situation that we don't want. And that's also why Carolina also focused on the circularity, because a crucial element and a learning point in this life cycle assessment is that if you use biogenic building materials, you should make sure that you can disassemble the building and reuse the building materials for new buildings. If you don't, then you should not be allowed to subtract the biogenic carbon storage from your total life cycle impacts. And here is the building circularity for our building. As you can see, on the material covered, so the virgin material, it's fairly high, because as Carolina explained, the metrics is weight-based. So the concrete and steel is relatively heavy compared to, for example, timber and cellulose. So that's why this number of virgin materials is fairly high, and the renewable and recycled one fairly low. And also, if you look to the materials returned, you see also a relatively high percentage of disposal and downcycling. Again, for the same reason, concrete is fairly difficult to recycle or to reuse in a circular economy. Anyway, the number looks small, 24%, but Caroline told me that within this metrics, actually, it's a fairly high number. But I hope maybe that she can confirm that later as well. So I have at the end of my presentation basically 4 takeaways. So if you want to reach net zero whole life carbon, I think you should focus on the 4 following points. Foundations, as you can, you cannot avoid cement and steel, but at least if you use steel, make sure it's recycled steel. And if you use cement, try to find the low carbon type as possible. Nowadays, more low carbon cement is becoming available on the market. Everything above the foundation, everything above ground, use bio-based building materials as much as possible. And thirdly, important element is that you design for disassembly. So make sure that the building you are designing can be disassembled at the end of the end of life, so that particularly the bio-based building materials you can reuse for other buildings. If you do this and you still have remaining carbon that you need to compensate, rather have an oversized photovoltaic system and try to avoid offsets. Offsets is, for example, planting trees somewhere else to sequestrate carbon. But if you can avoid this kind of offsetting, do it through an oversized PV system. Then last but not least, indeed, as Henriette already mentioned, we had a look at our annual utility costs with the energy crisis unfolding. And because the electricity price went up with, well, here at least with 50%, we are a net producer of electricity, so our income for the sale of electricity went up significantly, almost to 300,000 forints on an annual basis. Our heating cost, which is firewood, is 95,000 forints. We have some costs for cooking, which is still on butane bottles. And we have, of course, we're taking drinking water, which is 135,000 forints. But if you look at the total, it became negative. So basically, the electricity is now paying for our other utility costs. And we are fairly unique in this sense because of a lot of hotels in Hungary, and I guess the situation is similar in the Slovak Republic. will close during winter because they simply cannot afford the heating bills. But also, if we hadn't had any solar systems, if we didn't use biomass but would be heating with natural gas, if we didn't collect rainwater for flushing the toilets, our utility annual utility bill would be $1 million forint. That's 2,500 euros approximately. And even if we, and this is for a well-insulated building, if the building would not be well insulated, then probably we would have been in the same situation that we had to close for winter. So this brings me to the end of my presentation. There are some previous webinars on carbon footprinting, electrical driving. Also through the Green Building Council, we did a green walk, so you can also walk through the different buildings and have a look at the pool. And the carbon footprint report, which I showed you on the first slide, can also be downloaded from our website. So thank you very much for your attention, and I give the word back to Harriet.
Thank you very much, Lennart, for your presentation, and for Carolina as well. Okay, you stopped sharing your screen, and now this is time for questions and comments, if you have any questions. So we received the questions in the Q&A window, and Carolina answered it in typing the answer in the window. But maybe it's worth to have or answer the question live, maybe. So the question was that, what is the average office building embodied carbon level in Europe? And Carolina, can you please answer it live?
Yes, so I actually got the data from Hungary, and the data in the third quarter of 2021, according to our benchmark, it would range from the A grade to those below 250 kilos of carbon per meter to the G grade, those that have over 700 kilos of CO2 per square meter.
Okay, thank you very much. We got another question in the Q&A window, and it is about the impact of the solar panel production and transport here in Hungary. The question is how green solar panels are. This is a good question. I don't know who would like to answer this question.
I can give it a try. Yeah, it's a good one. Of course, you know, with the production of panels and the transport, you do have carbon emissions. I don't have numbers on the top of my head but of course your solar panels, they have a lifetime. Normally they guarantee it for 25 years, but in practice they will be able to work longer. So definitely they you know, will have to work some time to compensate the production emissions, but at some point they really become fully green and you know, deliver carbon-free electricity. And actually, if I'm correct, also in the software, the green electricity is not zero carbon, but it also reflects the emissions that were you know, produced when the panels were made.
Yes, thank you very much. And we have a question live from Gábor Szarvas, and I try to allow to talk. Gábor. I ask you unmute yourself.
Okay, can you hear me now?
Yes.
Okay, thank you very much. I actually want to just make a remark rather. Obviously, I represent Greenbourse, which was mentioned by Lennart as the company who was helping to review the calculations. And I must really say that we were really honored to be able to contribute this project, because I mean, we believe it's truly an exemplary construction project in Hungary, and it's so it was really a pioneering approach to the whole setup. So from the design through the construction, and yeah, including the circularity concept, which was, yes, as Lennart mentioned, wasn't even sort of so well known at that time. But essentially, if you want to focus whole life carbon neutrality, then this is absolutely necessary. And another important aspect is also, it was highlighted that so this project was, you know, achieving this neutrality without any offsite compensation. So offsetting is obviously a possibility for everyone, but then I mean, if you can, and this was an example where within the boundaries of the project, this neutrality could have been achieved. So this was very much, you know, an honor for us to be able to work on this project, because we also believe that this is, you know, really the next focus for the whole building industry. So we are, of course, today with in the middle of the energy crisis, very much concerned of you know, operating energy and operating operation-related emissions. But the embodied carbon, so all the carbon which is linked to the building materials and the construction itself. I mean, this is something which we should not forget, and this is also something with the World Green Building Council is clearly you know, raising more and more awareness of. So as it was also mentioned, this is something for every developer to consider, and not, you know, in the long time future, but actually should be doing it today. So when yeah, we were approached by Lennart, and you know, he did not mention I trust because it's well, not yet public, of course, that the project is hoping to become a case study not only in our GreenTalk, but ideally in the World Green Building Council library as well. So and in order to become, you know, a case study there, it was a requirement to have an independent review undertaken. So that was essentially an important trigger for having us also involved and doing this review. And I really hope that this is you know, going to happen, that this case study will be also selected on this global library. So we were just yeah, again, to say that how happy we were to be contributing. And I mean, not too important, but I wanted to mention that we did this on a pro bono basis, because we really believe it's an exemplary project, and I just really hope that more developers will follow suit. So thanks again for the presentation.
Okay, thank you very much, Gabor, for your comments and the extra information you shared with us. We have 2 comments in the Q&A window. Both of them is about PV panels. One expert says that he read that typically the carbon cost of panel production is paid back in 1 year of operation. So I don't know, would you like to comment on this? Someone?
No, thanks for looking it up quickly on the internet.
Okay, thank you.
Yeah, I just want to say that from what I have seen, it's about that 1 to 2 years, depending of the manufactured materials and transport as well. Yeah.
Yeah, and there is another question. Maybe you are not the not the person who should know the answer on it, but there is a question that a new regulation in Hungary don't support PV grid export anymore. So avoided emissions by PV surplus for reaching net zero carbon has big obstacles today. So what do you think about this?
Yeah, it's true. It's a temporary measure by the Hungarian government for new projects, for new PV systems. So, for example, in our case, this restriction does not apply. They mention the reason is that the grid simply cannot handle all the electricity supply to the grid. Again, it's a temporary measure. I hope that the Hungarian government, will start investing in grid capacity. I think Hungary is not unique in that. I mean, I know, for example, in the Netherlands, there are also really some issues to get PV systems connected to the grid. Of course, politics come in, so the Hungarian government says we only can do it once Brussels starts paying us again, but I think they shouldn't wait for that.
Okay, thank you very much for your answer. And there's a question to Carolina. What is your experience with your clients when they do life cycle assessment? What should they pay attention to when they assess their building for circularity? What are the typical challenges? What are learning points after the assessment? So this kind of questions raised.
Yeah, so the typical challenges, I think they are mostly some that Leonard mentioned also. For example, the types of materials, are they biogenic materials or not? Do they have very high emissions, or like he called the concrete like a dirty material? So I would say the most challenges are choosing the correct materials that will actually work in a way for building circularity. So I would say the choice of the materials. Also, transportation, for example, is something that really needs to be taken into consideration, and the end of life process as well.
Mm-hmm. Yeah. Thank you very much for the answer.
Yeah, and if I can add, I mean,
yeah, of course.
Yeah, that's why I think it's a very good tool, because it really makes it visible. And like I mentioned with the roof tiles, if I had known that time that clay roof tiles are so carbon intensive, I probably would have looked for alternatives. And yeah, of course, this software, like Carolina correctly mentioned, you should use it as soon as possible, because the earlier you use it in the designing phase, the easier it is to reduce your carbon footprint.
Yeah, definitely. Thank you. And there is a question regarding the water recycling and water treatment. I don't know, are you experts in it or not? But the question is that are there any good points for water recycling and treatment in factories or other buildings?
Well, water recycling is always good, because you simply reduce the water consumption this way. We've all seen this year now what climate change means in practice, and it also has an impact on water supply. It was a very dry summer in Europe. I cannot talk specifically about factories, but we are through this rainwater usage collection, we save about 45% on tap water. So instead of the tap water we're using the rainwater. It's actually not. It's the flushing of the toilets, but the biggest savings is in the laundry, because as you can imagine, people sleep for 2-3 nights in a bed, and you have to wash it, the bed linen, and that's significant amount of water you use, and that's 100% on rainwater. And on top of that, we use much less detergent, because the rainwater is very soft, and if the water is soft, you only need 1/3 of the amount of detergent than if you use tap water. So another way of saving.
Okay, thank you very much. And we have time for one last question, and maybe it's quite important, the return on investment on your project, Leonard. Can you tell some words about it?
Well, the project is about 30-35%. The investment was 30-35% bigger than a standard holiday resort or standard building. Return on investment is difficult to say, because it's a building, so it's not like that you get your investment back in 10 years, because a building still remains has a value. We designed it also in such a way that you can even use it as a regular home, just for living. So we didn't do that calculation. However, now seeing the energy prices, then probably we would have been wrong, because the payback time goes back dramatically because of the energy saving.
Yeah, circumstances count.
Yes, it's difficult. Nobody could have predicted this, I guess.
Yes. So thank you very much for your presentations. There is one more question live. I give you word, Paul, in a minute, but I would like to tell that I forgot to tell you that the links that Leonard put on the last slide of his presentation will be shared with you after in a follow-up email, because we don't share the presentations themselves, the materials, but we share the recorded video, and we will send you the follow-up email. So I give you word, Paul, in a minute. Just a moment. Okay. Just unmute yourself.
Can you hear me?
Yes.
Okay.
Fine.
Hi, both of you, Leonard, old friend, and Carolina. Nice to meet you, and was nice presentation. I just wanted to draw the attention. I mean, obviously, Leonard and his project has been part of our Hungarian operation for some times, because it was from the very beginning there was an intention, without using this fancy word of carbon neutral life cycle, so on and so forth, of making a low sustainability footprint or a low sustainable impact project, and I think that the history of this development represents the intention of the developer or the people who were associated with it, is to design this nature, as we say, and retesting the project into this more rigorous assessment system should itself, how should I put it, should itself give us some idea of how far, when we face the market, when we face clients, when we face our own work, we should rely on our own intuitive and common knowledge sustainability principles, and how far it will require such a rigorous testing as the one click is proposing, because from the just from the presentation, one would feel that it's not robust enough. I mean, essentially, the outcome is very robust, it's very visible, very good graphics. But getting all this information, and especially as you mentioned that many of the traders, many of the building materials are not listing the carbon content at the moment. So we need to find a kind of learning experience of how far a design and development, which essentially takes on the aspiration of remain sustainable, is a sufficient base to move forward rather than to wait for this extremely rigorous calculation. And I didn't catch, there was a remark from Leonard whether when the project was run through through your system, Caroline, that you had difficulty of actually finding numbers, even in a post-evolution stage. So that's the kind of question I would like both of you to answer of what's the practical way of going about it.
Well, just referring, indeed, I mean, for some major building materials like the cellulose, for example, we got it from Germany, and there they had it. On the concrete, for example, yeah, that came from a local, the nearby concrete factory, and of course, it doesn't make sense to transport concrete over long distances. So we simply took the concrete that was close by, and they probably have never heard about an EPD. On the other hand, I don't think, yes, this is very rigorous, this calculation, but even if you just simply use default values, you already get the insight, in my view, that you need to adjust your design in such a way that your carbon emissions go down.
Mm-hmm.
So we don't have to look behind the dots, it's just to get a feeling on where your emissions are. And even like for me, as I'm in this carbon business for a long time, I learned a lot just by simply inputting some basic data into the software. But of course, it's like you said, yes, it's our intention to maximize on sustainability. You would expect, I mean, that other designers would have that same intention. If they just want to optimize the software to get the required results without the proper intention, yeah, with any system, with any software, you can of course play around a bit, trick around, I would even say.
Just to add on that also, I think that you are also asking about data availability. And in our software, we do have the EPDs, the environmental product declarations. But for example, for the case of not having enough EPDs for a certain location, because it's not always that all the manufacturers are going to issue EPDs on all of their materials, then we do have generic materials that can be used, or materials from neighboring countries that can be also used with the localizing factor, which is basically substituting the electricity profile so that we can use the material as if the material has been produced locally. So this is a solution also for this. And also, as Leonard was mentioning about playing around, you can also do it in the early stage of the project. For example, when you have only very little information, like the area of the project, how many floors it will have. So we have a tool, the Carbon Designer 3D, that you can do the input of this information, and then it's going to generate some very much simple building, like a shoebox shape. And then you can have an idea of building that size with that area. How much would you have in terms of emissions, also based on the materials type of frame that you would choose. This is something that has also been very much used in universities that have been working with on-click LCA to work together with building circularity as well.
Thank you.
Thank you.
Thank you very much for your answers. And I think that the EPD, the Environmental Product Declaration, can be a topic on another green talk. But one of our members just wrote an article in Magyar Építéstechnika. This is a Hungarian professional magazine about EPDs and the whole life carbon itself. So you can read this article as well. So thank you very much for your presentations of today and the questions. And I think it was now a nice discussion among the participants as well, because the topic is very important. So thank you very much to be that you were with us. And let me invite you to the next event as well, our last Green Talk during the year. It will be in the end of November, the 23rd of November at 3 p.m. And we will speak about the energy refurbishment of existing buildings. So in another quite interesting topics. And we will share best practices from HuGBC members at Science Park offices. So I encourage you to join us. And for now, I really thank you very much for your attention and have a nice rest of the day, all of you. Thank you. Bye-bye.
Okay, thank you very much.
Köszönöm. Thank you.
Thank you.
Kiitos.